be verbalized.
Okay. Open up my horrible writing program. As long as I remember to go top to bottom, I should be able to make it work. Okay. What do you got for starters?
So right now we're going to we're going into a unit talking about derivatives, and it's on like the implicit derivative and the chain rule, and then related rates.
Refresh me again. You're taking Calc AB non-AP?
I'm in precalculus right now. Honors trig precalc.
That's what I thought. Okay. So you're in the second part of pre-calc where they get in really the derivative calculus.
Yeah.
And that's why you're getting this stuff. Okay, that's fine. So you want to read some of the problems and we'll do them?
Yeah. All right. So one of them is just find the derivative of the function. Okay. And the function is f of t equals 5 secant cubed of pi t minus 8.
Excuse me, of 5 pi t minus 8?
What was it? No, just pi t minus 8.
All in parentheses?
Yep.
Like that.
Yeah, just like that.
Okay. So this involves a couple of rules of chain rule applications.
Okay.
Okay. What's the first inside? In other words, when you have two applications of chain rule, work from the outside in and tell me what the first inside is. If I had to say let u equal something, which is always the test as to what the inside should be, what would u be?
Would it be pi if it's talking about the inside, like within the parentheses?
No, I can understand why you would say pi t minus 8. That is u, but that's the second u. In other words, you started me off with a really hard one here, okay? Which is fine, okay. But it's just two applications of the chain rule. The first inside is actually secant of pi t minus 8. Okay? And okay. The reason that is that what we really want is 5u cubed, right?
Yeah.
We know how to take the derivative of that. The derivative of that would be 15u squared times du dt. So let's figure out what du dt is. What is that over here on the right?
Let's see here. Is it?
It's the derivative of secant.
Okay, so
that's
it's
the first thing you need to ask yourself is what is the derivative of secant?
All right, so then that'd be oh gosh, is that the secant tangent?
Yep. So it's secant tangent, same argument. Now you have to apply the chain rule a second time here. In other words, we need the derivative of this inside. So what's the derivative of that?
The derivative of that is pi.
Correct. So I'm going to write that in front over here. So that's what du dt is. Okay? So now if we go back to this function over here, we got 15 u squared du dt is pi secant tangent of pi t minus 8. And now one last substitution. We want our final answer to be all in t. And right now we have it in u and t. So let's go back in and substitute for that. So it's 15 secant squared pi t minus 8. That's what u was.
Okay.
Pi secant tangent of pi t minus 8.
Wow.
Yep. When you have to apply 2 levels of chain rule, they get complicated fast. Especially when the first derivative of secant is secant tangent, which expands it already. But notice that we really applied the power rule to that, but then the inside of that was secant. So we had to apply the derivative of secant, which is secant tangent. So, all right, let's go to the next one.
All right. All right, so find the derivative of the function where y equals 9x over the square root of x squared plus 4.
Okay, and they want to find y prime?
Yep.
Okay. What should we do with radical signs when it comes to calculus?
You multiply or get rid of the radical and just put in parentheses and do
Hold on one second. I got too many dogs going off here. I need to close my door. All right. So how should I write this?
Would it be 9x times in parentheses x squared plus 4 to the negative 1/2?
Actually, I like that. That's a little bit out of the box because I had another choice. Could also written it like this. Notice the difference. If I write it like that, I got to use the quotient rule, right?
Yep.
If I write it like that, I can actually use the product rule. No quotient rule. If I write it like this, I can't use either one because it doesn't know what to do with the radical sign. So the first step is always to get rid of the radical sign. And the way you did it actually produces the easiest way to then differentiate it because you can use the product rule, which is simpler than the quotient rule. Wouldn't you agree? Quotient rule is harder to memorize and harder to actually do. So let's use that one.
All right.
So here's what the product rule says. If y equals one function times a different function, then y prime equals u times v prime plus u prime times v. So that's what we're going to do. There's our u. There's our V.
All right.
So
then,
what do we got? And you know, even though you can reverse those, I really highly recommend always doing it the same way. And the reason is that then there's no questions about how you start. You always start with U. You don't start with the one that's the easiest to differentiate. You start with U.
okay.
Even though you could start with U prime times V and add it to the reverse, if you always start with U, I guarantee you'll find it easier. In other words, in this particular problem, we don't sit there and spend a minute trying to figure out, well, which one should we differentiate first? Yeah, just start with U. There. Now,
that would be
V prime.
9x times,
I'm sorry.
is it 9x and then the u, or the v prime is negative 1/2 x squared plus 4 to the negative 3/2?
Now there's more to that though, because we're looking at a chain rule application. So what does that whole thing need to be multiplied by?
By the inside again, so 2x.
Derivative of the inside. So I'm going to write that right there, because that's not affected by that exponent. Okay, so now I can simplify a little bit here. Those 2's cancel. So I've got a minus x times x squared plus 4 to the negative 3/2. And that is probably the answer. I don't see, I guess I can take that x out and make it minus 9x squared, huh? I don't see why I can't do that. I generally want you to simplify it where it helps. And that definitely helps. And
Okay.
It's not 9x minus x. It's 9x times a minus x. So I can go ahead and multiply those two together. And I can't do anything with simplifying that part because that whole thing is being taken to a fractional exponent. So I think this would be your answer. Now, some teachers will tell you that if they give it to you in radical form, give it back to them in radical form.
All right.
I don't know if your teacher, do you have answers to these?
Yeah, it's on a website, WebAssign.
Look it up real quickly and tell me if this is his answer or he gives it in radical form, and then we'll know how to proceed.
All right, so then it's negative 9x squared.
Hold on. I've completely screwed this up, I believe. Yeah, I did. Just a second. That's not the answer.
Okay. Did we forget to do the second half of the product rule?
Yeah, we did. Thank you very much. That was the first half of the product rule. Right. So what's the second half?
Now it'd be 9 times x squared plus 4 to the negative 1/2.
Yeah. In other words, it's not real complicated, but it does change. I guess I can go ahead and write that. It didn't change the thing that was on the left. So I can do this. And that might be the answer that you get when you look it up.
Okay.
Go ahead and look it up and let's have a look as to whether or not they want it in radical form or not.
All right. Plus 4 to the negative 3/2. Have you ever had anybody that's had or worked with WebAssign before? It's a newer online
I don't
software.
believe I have.
All right. Then I'll be your first one. But
Yeah.
it's.
Usually
Have you ever heard of
it doesn't
that?
make it easier. Usually when you have internet websites and calculus, it makes it a lot harder because you have to put in the answers exactly right.
Oh yeah. I'm not a fan of it at all, but my teacher loves it.
To be honest with you. But if that's what they give you to work with, that's what you gotta use.
Yep.
They conceivably could reduce or reverse the order of those two things, because this one would make it 9 of those minus 9 of those.
Yeah. All right. That was the correct answer, though.
It was? Okay. All right. What else do you got? And they put it in this format. They didn't force you to put it back in radical signs. In other words, this part over here is, I could have written that as 9 over the square root of x squared plus 4, like that. And some teachers might require that because they gave you the answer like that. In other words, I'm sorry, they gave you the function in radical form, so they may want their answer in radical form. I just don't know.
Okay. All right. The next one says find the derivative of y with respect to x by implicit differentiation.
Okay.
So it's 3 cosine and then in parentheses 2x and then times the sine of 9y in parentheses equals 1.
They don't exactly start you off with the easy stuff here, do they?
Oh no.
All right.
2x is or there's a parenthesis right after the x in the cosine of 2x, and then the sine of 9y is separate.
Ah, like that. Okay.
Yeah.
The concept of implicit differentiation is actually a relatively easy one. Let's take a simpler example over here on the far left.
Mm-hmm.
The equation of a circle.
Okay.
Find dy dx. Okay? Notice that this isn't that easy to solve for y. So if I solved for y, then I could use all of the rules we have for explicit differentiation. But it turns out that implicit differentiation is actually what you always want to use, and it's not as hard as it sounds. If I want to find the derivative of the left side relative to x, well, when I come across a variable that's x, is all I need to do is differentiate it. But when I come across a variable that's not x, doesn't matter what it is, if it is an x, then I differentiate it, followed by a dy dx. Have to differentiate the right side. So all I've done is differentiate both sides of the equation implicitly. Now, notice what happens. That's what they want, right?
Yep.
So if I algebraically solve for dy dx, I get minus x over y. That's my answer. So when you implicitly differentiate, you frequently get an answer that's not in terms of x, but in terms of x and y. And that's fine. That's a classic symptom of implicitly differentiating, is you get your answer in terms of both variables. And only rule you really need to apply is that when you come across a variable that is not this, x, then you have to follow that. In other words, if I started with x squared plus y squared plus z squared equals 1, then I would get 2x plus 2y dy dx plus 2z dz dx. In other words, whenever I come across a variable that is not x, I have to follow it by d of that variable divided by dx. So that's the rule. That's the only rule. Okay?
All
So
right.
let's tackle this. What's the first thing I can do before I do anything?
The first thing you do is
I'd say
do the
let's get rid of
differential.
that 3. It's simple enough to do. I can divide both sides by 3.
Oh, okay.
Okay? So now we got that. Now I'm going to implicitly differentiate it. Now I've got a product rule because I got that times that.
All right.
I've got a chain rule because I got an inside there, and I'm going to have an inside there. So I'm going to have multiple applications of the chain rule here. So it's not like they started us off with an easy one here. Okay. So remember that when you are implicitly differentiating, so we're going to start with the product rule. So what's the very first thing I should write? And I'm going to differentiate. Here's what I'm going to do. I'm going to differentiate the left side with respect to x, and I'm going to differentiate the right side with respect to x. Okay, so that's what I'm doing. So differentiate this top left side.
All right. So then is that negative sine of 2x times 2?
Hold on. There's a reason that I tell everybody to do this. And that's so that I can follow them. Notice I always start with u. And I do v prime
Okay.
plus u prime v. Now, doesn't matter which order you do those in. You happen to do that order first. That's fine if that's the way. Is that the way you always do it? If
That's
the way you
the way our
always do it, then I'm not going to mess with it.
That's the way that our teacher taught us how to do it, but
That's the way we'll do it then. Okay? So that's fine. So the first thing you're going to do is u prime. Okay. And u prime again was minus
sine 2x times 2.
finish up.
Yep. And then times the sine of 9y. And then plus cosine 2x times the cosine of 9y times 9.
One last thing. We ran into a variable that was not x. So what do I have to follow that by?
The derivative, dy over dx.
That's important because that's what we're solving for. And right now, that's the only place that appears. Now it's just an algebraic solution.
Okay.
Okay? You want to go through the algebraic solution or you want to go to the next problem?
I think we can move on to the next problem.
Yeah,
That should be good.
I think you're comfortable with the algebra here. In other words, there's our dy dx. Now, occasionally these can be complicated because you can have multiple dy dx's. And then you have to gather them together, factor them out, and it introduces an extra level of complexity. And hopefully we'll get one of those. Although they're not exactly starting out with easy problems, but they're not giving you problems yet that require that technique.
All right.
Let's see if we get one. What else you got?
Let's try this one. Evaluate dy over dx by implicit differentiation and evaluate the derivative at the given point. And so the equation is x cubed plus y cubed equals 6xy minus 1 at the point 3, 2.
Now, notice when I originally said that you end up getting your answer in terms of x and y. So when I go to evaluate it, whatever I come up with for dy dx, I'm going to plug in 3 for x, 2 for y, and evaluate that. In other words, it's not a bad thing to have your derivative in terms of two variables because you usually get an x and a y. If you get just the x, then you got to solve this original equation and come up with the y. And they've made that particularly tough to do here because you'd be hard-pressed to solve this equation for y. In other words, if we didn't have implicit differentiation, then we would have to solve this for y, right? Why? How are you going to do it? That's a cubic. I don't know how to solve that for y. I bet you don't either. And which means we would not be able to explicitly differentiate it. But implicitly, it'll be a piece of cake. Just start from left to right. We're going to implicitly differentiate the entire left side, then the entire right side. And this is where we'll end up with multiple dy dx's, which we'll have to gather together. So this will definitely be a little tougher. But let's get started. Start from the left.
All right, so that'd be 3x squared plus 3y squared times dy over dx equals 6 times dy over dx. Yeah?
Second part of the product rule. That's just first part.
Oh, yeah. 6 times dy over dx. And then plus 6x times y? Or did I mess that up?
I think we messed it up here. It was my fault for not catching it. That's because I'm still stuck in my old mode. Okay, so you took the derivative of the first.
Yeah, so 6
times the second.
times y.
That does not require a dy dx following it because I did not take the derivative of y. I only took the derivative of 6x. Okay. Plus, now it's 6x times the derivative of y, which is 1. Since I am taking the derivative of y, I need to follow it with a dy dx. And we still have minus 0 because that goes away. Right?
All right.
Okay, so this is a little extra difficulty here. What's one thing I can do immediately that will simplify the problem?
Subtract 6y from the right?
Well, I was thinking divide everything by 3.
Oh, yeah, that works.
Let's just do that, just for no other reason than it makes all the numbers smaller. Okay? Now, we haven't done one like this yet. We've got multiple dy dx's. What is the next step? This is critical.
Now you try to get everything with dy dx on the same side, right?
Let's do it. And then everything that doesn't have dy dx in it goes on the other side.
All right.
So what's our left side going to be?
Should we make that one the dy dx side then?
Yeah, I like to. Just, that's my preference, but we wouldn't have to. We could always do it the other way. There's no particular reason to put it on the other side here. So I would say let's put it on the left. So here's what we have over there already that has a dy dx in it. Now, let's take this and move it over there. So what does that become?
Negative 2x times dy dx.
Now, everything else needs to be on the right side. Well, we had this thing on the right side already. And this needs to go over to the right side. With me?
All right. So then,
Now, these two steps where everybody gets tripped up, going from here to here, and then the next thing you do. What's the next thing to do?
factor out the dy dx.
You got it. Leaving behind what?
Y squared minus 2x in parentheses
And now what?
equals 2y minus x squared.
And now what?
And then you would divide by the y squared minus 2x on both sides.
And there you have dy dx. And we were evaluating it at what point? 2, 3 or
3, 2.
3, 2. That's easy.
So then
It's 2 times 2 minus 3 squared, all divided by 2 squared minus 6, which is 4 minus 9 minus 5 in the numerator, 4 minus 6 minus 2 in the denominator. That should be your answer, 5/2. And what that means, that's the slope of the line at that point. In other words, we look like we are looking at some sort of an ellipse. Okay? An ellipse that might be like that.
all right.
And they want to know what is the slope when x is equal to 3 and y is equal to 2. Well, let's call that 3, 2. And we were able to calculate it using implicit differentiation and only implicit differentiation. And it came out to be 5/2. In other words, that's the slope right there at that point. And the fact that we needed an x and a y doesn't matter. You'll always be given an x and a y if you need both of them.
All right.
Okay. Hopefully I didn't make any math errors. It's, as you have discovered by now in calculus, boy, you better be a perfectionist. Because every problem has like 10 steps. And if you do 9 of those steps correct and you make a mistake on the 10th one, you're getting it wrong. You got to do 100%. You absolutely do. You got to get every single step correct.
Oh yeah. All right. This next problem, it says find the slope of the tangent line to the graph at the given point.
Okay.
And now the equation is parenthesis 10 minus x close parentheses times y squared equals x cubed. And the point is 2, 1.
All right. When they ask you for the equation of the tangent line, if you were giving somebody a calculus test and you could only ask one question, that would be it. Okay?
All right.
This is the definitive question, especially in differential calculus. Because what's the first thing you need to find the equation of a line? What's the most important aspect?
So derivative?
Slope.
Okay.
Slope. And you get the slope by taking the derivative. You find dy dx, you evaluate it at this point, that gives you a slope. And since you have a point and a slope, you can easily plug both of those into the point slope format for a line. That will give you the equation of the tangent line. And in calculus, the point slope format is far more common than the slope intercept format. The slope intercept format is really common in algebra 2, but the thing about calculus is what they're always giving you is a slope and a point, or they're giving you an equation where you can calculate the slope and they give you a point. So the slope point format, which is this, in case you have forgot it. In other words, when you get a point and a slope, if you plug it directly into that, you have your answer with no additional math. I'm going to plug in that as my point, and the only thing I need to figure is the slope. So let's go through the derivative of this and evaluate it so we can figure out what m is going to be.
All right. So then you'd just use implicit, right, with the product rule?
Yes.
Okay,
well,
so
well, your first step is you're going to differentiate both sides with respect to x. That's conceptually what you're doing. Just like with algebra, you can do anything you want to the left side as long as you do it to the right. And that will include you can differentiate both, you can integrate both, you can square root both, you can logarithmic both. Truly is universal. Whatever you can imagine to manipulate a function, you can do it to both sides of the equation.
Okay.
Do d the left side relative to x and do d the right side relative to x.
Okay. So then you would do, what would that be? -1 times y squared plus plus 10 minus x, there we go, times 2 dy over dx times 1.
First of all, explicitly differentiate it, which is 2y.
2y. Okay.
And you just have to follow it. Since we were differentiating y, we've got to follow it with a dy dx. That's the left side. Oops, hold on. Yeah, no, that's the full left side. I did both of them. Okay. What's the right side?
Is it just 3x squared?
Yeah, you don't have to follow that. And notice that even if we did follow it, it would be dx dx, right?
Yep, and that's just 1.
So, in reality, implicit differentiation covers all differentiation. Even if you never learned explicit differentiation, implicit differentiation would produce the same thing. Okay, so it kind of is universal. Now,
all right.
What?
Now you try to get the dy dx
Okay,
all on its own.
C is right there, so let's isolate that.
All right. So then
We'll
we could add
y prime instead of having to write that dy dx everywhere.
All right.
Y prime is going to be equal to what?
Y. So first you would add y squared to the, well, you would have your 3x squared, then you could add y squared to that, since y squared is -1.
Okay.
And then you could divide all of that by 2y times 10 minus x in parentheses.
Okay. And now evaluate that. In other words, what is y prime of 2, 1?
So then you would just do 3 times 2 squared plus 1 squared all over 10 minus 2 times 2.
And I really do think it's worth doing that. A lot of people do that math, some of that math in their head. Boy, that's a really easy way to make a mistake. Whereas if you do it this way, it's much harder. You still got one more step to go, but it's an easy step and you're not going to probably make mistakes. So that's 12 plus 1, 13 on top, all over 8 times 2, 16 on the bottom. So that's our slope. So that's m. There's our point. Let's come up with the equation of the tangent line.
Alright, so that'd be y minus 1 equals 13 over 16 times x minus 2.
And that's the final answer. In other words, you don't ever have to take that and put it into y equal mx plus b format. That's not the standard format in calculus. The standard format is point slope, and that's actually the point slope format right there. So they prefer you leave it like this, unless they expressly say, give it to me in slope intercept, and they'll never do that. Because once you get into calculus, point slope is far more valuable than slope intercept.
All right. I like that. It takes one extra step out of the process.
What's that?
I like that. It takes one step out of the process.
Yes, it definitely does. You don't have to solve for a b. And that would be tough to do with some of these functions because they're so complicated.
Oh yeah.
All right, what else you got? About 10 minutes.
All right, then I'll go
Two
for.
easy ones or one hard one, I suppose.
All right, let's go for. How's about a word problem? So
Okay.
this one's at a sand and gravel plant, sand is falling off a conveyor and onto a conical pile at a rate of 10 cubic feet per minute. The diameter of the base of the cone is approximately 3 times the altitude. At what rate?
Hold on. Hold
All
on.
right.
Diameter of the base of the cone is 3 times the altitude, right? That's what it said.
Yep.
So it looks more like this.
Yeah.
That's the altitude.
Mm-hmm.
That's the diameter of the base. Okay.
And then it asks, at what rate is the height of the pile changing when the pile is 12 feet high?
Okay.
And then it also gives you the formula for the volume of a cone.
Okay. Now, this is a related rate problem. Okay. Related rate problems are where they give you one rate, and they're giving us the rate that the volume of that cone is changing, right?
Mm-hmm.
So what that thing is right there is dV dt. That is the rate of change of the volume with respect to time. And I know it's with respect to time because it's got minutes. So that's equal to 10 cubic feet per minute. And it's plus. The volume is increasing. So
Okay.
what we need to do is figure out what is the equation of this underlying thing going to be. Then I'm going to implicitly differentiate that equation, and I'm going to come up with some of these variables, dV dt, where I can substitute that number. Okay? So
All right.
let's figure out what's the volume of a cone. They gave it to you.
It's 1/3 pi r squared h.
So we'll call that h instead of a. What other piece of nugget of information did they tell us about the relationship between the height and the diameter?
They're asking us to find it when the pile is 12 feet high, and just that it falls at a rate of 10 cubic feet per minute.
No, they also said the height was 1/3 the size of the diameter, correct?
Yeah.
That's really important. That means
All right.
height is 1/3 of d. And here's why that's important. Is because I'm going to differentiate this function over here to come up with a dv dt.
Okay.
But I want everything, if I can, I want it to be a single variable on the other side. I don't want multiple variables over there. Right now I have an r and an h. But the fact is that I can take my h and turn it into r. Since d is equal to 2r, then h is 2/3 d. So really what I have is v equals 1/3 pi r squared times 2/3 r. See how I get that? In other words, the height is related to the diameter, so it's related to the radius. So I can substitute that for height. And now I have a pretty simple equation that I can differentiate. Okay, let's first of all combine it before I try to differentiate it. I can certainly multiply the 2/3 times the 1/3, giving me 2/9 pi r cubed. Okay.
Okay.
Now, implicitly differentiate that.
All right.
What do you get on the left?
So
Incidentally, what we're doing here is we're implicitly differentiating both sides with respect to time. Notice that there's no time variable in either side here. So that means whenever we run into a variable, we have to follow it by d of that variable dt. So the first variable we run into is v. When we explicitly differentiate that, we get 1 followed by dv dt. Now do the right side.
Equals, would you have to do the product rule on the right side?
No, these are all constants.
Okay, so then it would just be, what would that be? 6/9 pi r squared dv or dr dt.
Huh? Perfect. Okay. Now, what they asked was, what did they ask? I'm sorry.
They're looking for at what rate is the height of the pile changing when the pile is 12 feet high?
All right. Here's what they're asking for, dh dt. Okay?
Okay.
Fortunately, I solved this for r. So let me go back to this step here. And instead of substituting for h, I'm going to substitute r. And then do the whole problem again. Okay? Now, r is, or rather d is 2r. So if I solve that for r, I get 3h over 2, correct?
Yep.
So now I'm going to go back into my original formula, this one at the top. And instead of substituting for h in terms of r, I'm going to substitute this in terms of r. Instead of substituting for h, I'm going to substitute for r. So I get
Alright.
v equals 1/3 pi. And instead of r squared, it's 3h over 2 squared times h. So now I've effectively made volume a function of height. Okay, and in fact, what is that? That's v equals, let's see, that's going to be 9/4 times 1/3. So that's going to be 3/4 pi h cubed. Correct?
Okay. Sure.
Now, implicitly differentiate that, and I'm speeding it up a little bit because I got off track.
So dv over dt equals 9/4 pi h squared dh dt.
There you go. Okay. Now, this is what they're asking for when h is what? 12?
Yeah.
And this is what they've given us. That's 10, correct?
Yep.
So, it's always the last step in a related rate problem, is to figure out what they're asking for. I got that. And where it occurs, because those rates are going to be different depending on what h is. So I'm going to solve this equation. When dv dt is 10, and h is 12, what is dh dt? How is the height changing with respect to time? Now, all you got to do is solve that.
Yep, just isolate it. Okay.
These are all numbers, so just an algebraic equation now. And notice that it will be a number of less than 1. In other words, the height is moving up by 1/2 of a unit per minute. Whatever the units were on the time in the original 10, that's the units that are going to be on this dt.
Okay.
Okay. Morgan, I have one last thing to ask you.
All right.
I sent out something. When I send out an envoice, I send it to your mom and your dad. But the one I sent to your mom came back to me. Is that her email address right there?
No, it's not. It actually just recently changed.
Can you give me her new one? She told me that if I want my envoices paid, send them to her, not your dad.
That's probably true.
Okay. Can you give me hers?
Yeah, it's Bridget Scherer. So BRIGETTE SCHERRER at hotmail.com.
Like that?
Yep, just like that.
Okay. Thank you very much.
Sure thing.
Appreciate it, and I will talk to you next time.
All right. Thank you so much.
All right. Bye-bye.
Bye.